Okay, so in our first story problem, we have Natalie and Renzo, and they like to do puzzles. So, Natalie can finish a 500-piece puzzle in about 8 hours. So that would be by herself. And when they work together, they can finish a 500-piece puzzle in about 4.5 hours. Okay, and then what I want you to do, so it says question to answer, I want you to either underline that or highlight it. What is the question that we have to answer there? Okay, so what is it? What is the question we're answering here? How long will it take Renzo to finish that puzzle if he works by himself? So whenever you see the how long, that indicates what you're finding is what? Time, okay? So we're going to find a unit of time. Okay? So our important information, we're going to talk about that. So we have Natalie, who can finish one puzzle in 8 hours. One puzzle, 8 hours. Okay, and then we have Renzo. One puzzle in, we don't know, so let's call it H hours. Okay, and then we know that together they can finish it in 4.5 hours. Alright, so what we can do is we can think of Natalie and Renzo. We can think of their one puzzle in 8 hours as a rate. So remember the equation that we were talking about yesterday? Did I say puzzle that we were talking about yesterday? Did I say the puzzle? Okay, good. Alright, so the equation we were talking about is the distance equals the rate times the time. Okay? We are going to use variations of this. So if this is our main equation, the distance equals the rate times time. If you wanted to solve for the rate, what would you do to both sides? Yes, divide by t, divide by t. So it would be the distance over the time is the rate. Okay? So let's think of the way that they're working as a rate. Okay, so for one puzzle in 8 hours, in this case, our distance is the puzzle. That's what they're finishing. Okay, so this would be one puzzle in 8 hours. The reason why it's a fraction is it's d over t. So the distance is one puzzle, the time is 8 hours. For Renzo, the distance is still one puzzle, but this is going to be in h hours because this is what we're trying to find, is how fast he could do it by himself. Okay? So each person gets a rate. Now, the equation that we're going to set up is going to be the distance equals the rate times the time. Okay? But we have to do that for both people. So, what we're going to set up, what we're going to solve is first the distance. I'm going to put it on this side, but the rate times the time is going to be the time together. Okay? And actually, I'll write this here. So distance equals the rate times the time is what we're using for our rationale. Okay? So in this case, we have 2 people, so we're going to have 2 rates, and we're going to have 2 times. So we have Natalie, which she does 1 puzzle in 8 hours. The time that we're going to multiply is their time together. So this is going to be your t value. So 1 over 8 times 4.5 plus Renzo is 1 over h times 4.5. And that's going to equal the distance, which is 1 puzzle. Now this setup you can use for any problem that's like this, okay? So it's the rate times the time together, the rate of the other person multiplied by the time together equals 1. And again, the setup comes from this. The distance is 1 puzzle, you have 2 different people, so you have the 2 different rates there, okay? Now we just have to solve this equation. So when you have a whole number times a fraction, do you guys remember where you put it? 4.5 gets multiplied by which part? The numerator. So it will be 4.5 over 8 plus 4.5 over h equals 1. And just as a hint, whatever they're doing is always going to be one whole project, one whole task. Okay? Oh, and I'm actually going to write out the equation for you so that you can always do this. So you're always going to do the rate times the hours plus the rate times the hours equals 1 complete task. In this case, the task is the puzzle. Okay, but you'll have different examples where they're painting a room together. I forget what the other ones are. They're doing all sorts of crazy. Okay, and then so the rate is of the first person, so the rate, this would be of Natalie, the hours together. The rate for Renzo, or Ren, the hours together. And that's exactly what we set up. Natalie's rate times the hours together, Renzo's rate, the hours together, equals 1 complete job. Okay, so if we're going to solve this, you guys already told me earlier today, what we did yesterday was we multiplied by the LCD. So what's my LCD for this equation? Yeah, so we're going to multiply both sides by 8h. And you don't have to worry about the look back. The look back, I mean, you don't have to worry about leaving room for it. Okay, so the look back is, does your answer make sense? So once you solve this, okay, we'll make sure that this falls in a parameter, okay? All right, so if you multiply both sides by 8h, remember yesterday how we set this up? 8h times 4.5 over 8, we're going to distribute it, plus 8h times 4.5 over h equals 1 times 8h. Okay, so we're going to multiply both sides by the LCD. Okay, so I'm going to give you a minute to simplify that. then you're going to solve the equation for H. So once you do your cancellation, alright, so let's check in, make sure we're at the same spot. So remember, the whole reason why you're multiplying is so those can cancel, right? So if those cancel, you're left with h times 4.5, or 4.5h, right? Here the h's cancel, so you have to multiply 8 by 4.5. What's 8 times 4? 32. What's 8 times a half? 4. So together they make 36. No h's because they canceled. And then on this side you have 8h. Okay, so now to solve for h, we have to get all h's to one side of the equation. Okay, so I would move the 4.5 over. Okay, and then do 8 minus 4, which is 4. 4 minus a half is, yeah. And you can use your calculator for this, okay? Alright, so then let's divide. Did you want to do this part? Good. Alright, we're going to round this to the nearest tenth, and then h, in this case, represents the number of hours. So this is going to round to about 10.3, okay? But when we're talking about time, right, we want it to make sense in the real world, okay? You're not going to say, alright, hey, Mom, Dad, see you in 2.6 hours. Right? That's weird. Well, maybe you do. I don't know. And if you do, that's cool. I'm sorry. Not weird. You do whatever you want. But usually, when we talk about time, we talk about hours and what? And minutes. Right? Okay, so the 10.3 hours, let's just change the 0.3 hours to minutes. So how can we do that? So you can just multiply. This is hours, right? Are a lot of you in chemistry this year? Okay, so 0.3 hours you would multiply by, if we want to change it to minutes, how many minutes are in an hour? 60. You guys been doing these conversions? Where you guys get to slash in there? Slash the hours, you're left with the minutes. So 0.3 times 60 is, what's 6 times 3? 18. 18 minutes. Alright, so together it takes them 10 hours and 18 minutes. Alright, so let's make sure that that makes sense, right? So you have 10 hours and 18 minutes. Okay, if they have the same rate, how many hours would they be able to do it in? They have the same rate. They could both do it in 8 hours, then together they could do it in what? 4 hours. But see how this is more than 4 hours? So that means Renzo is going to take a little bit longer. That's what brings that up. Okay, so that does make sense in terms of the problem. Okay, so that's the look back. Does your answer make sense? So yes, it does. All right, now we are going to go on to inequalities. Now, inequalities have some special rules when you are solving them. Do you guys remember any of the special rules from inequalities? There's one main thing you have to look out for. Yeah, when do you flip that sign? When do you have to flip the sign with the inequality? Yes, if you divide by a negative, and it also happens when you multiply by a negative. So if you multiply by a negative or divide by a negative, okay, then you have to flip the sign. So that's going to produce some problems for us when we're trying to solve, and we're going to have to consider a few different cases. So we're going to solve the inequality algebraically, Your book also goes over a table and graph method. We are not going to do that. So for all the ones on your homework, you're going to do it this way. So no matter what the directions say, you're going to solve with algebra. And I did put that in the calendar. Make sure that you just solve with algebra, okay? All right, so with inequalities, we have to be careful. We have to watch out when you divide or multiply by a negative. Do you like my watch out today? It's like, oh, what's happening? Are we multiplying or dividing by a negative? Okay, so when we are solving these, okay, we're going to have to consider two cases. All right, so let's look at this one. Let's look at part A. So we have 6 over x minus 8 is less than or equal to 3. Okay? Now when we're solving, and we've done this before, you don't have to write this. You don't have to write this part down. But if this, in fact, don't write this part down. But if we were solving this, what would you do to both sides? Yeah, you multiply by x minus 8. Okay, so we want to do the same thing to solve that. The only thing is we don't know if it's positive or negative. Okay, so the LCD in this case is x minus 8. We need to multiply by x minus 8, but don't know if it's positive or negative, so we consider both cases. Okay, so this is the whole reason why we have to do this. Okay, we need to multiply by x minus 8, but we don't know if it's positive or negative, so we have to figure out what's going to happen if it is positive or if it's negative. And it goes back to this, because when you divide or multiply by a negative, the sign flips, right? The sign switches. That's what we have to watch out for. Now, it's only when you multiply or divide by a negative. So we have two cases. The first case is that the LCD is positive. Okay? So we're gonna do this case together, and then I'm gonna write out directions for you after we do the steps, okay? All right, so case 1, the LCD is positive. The first thing that you want to do in case 1, okay, is solve for x. Okay? And so I'm just going to write step 1, solve for x. All right, so we have 6 over x minus 8 is less than or equal to 3. You guys already told me what to do here, so we're going to multiply both sides by x minus 8. Alright, and then they'll cancel here. So I get 6 is less than or equal to, and we are going to distribute here. So 3x minus 24. Okay, solving inequalities is very similar to solving equations. You're going to move numbers to one side, variables to the other side. Divide by 3, and you get 10 is less than or equal to x. Now, whenever you write an inequality, you are going to want your x on the left side, so I'm just going to write this as x is greater than or equal to 10. That's your step 1. And again, I can just switch it because when you guys learn this, you learn about the alligator eats the bigger number. Okay, so alligators chomping on x here, chomping on x here. Okay, so same thing, we're good. All right, now step 2 is where we consider the cases. Okay, so step 2 is consider the positive and negative LCD. If the LCD is positive, that means the LCD has to be greater than what number? 0. If it is negative, which we'll do in a moment, then the LCD would be less than 0. Okay, so that's what we're going to do for step 2. So consider the positive and the negative. So if the LCD is positive, we're going to set the LCD greater than 0. So what has to happen for this inequality to be true is x has to be greater than or equal to 10, but we also know that x minus 8, that has to be greater than 0. And the reason why is because we're saying that the LCD is positive, right? If it's positive, your sign's not switching. So now we have to solve this, which is just adding 8 to both sides. So x is greater than 8. Okay, that's step 2. Step 3 is going to be to simplify the two inequalities. So you simplify the two inequalities which is really, you're just seeing where they overlap. Okay, now I feel like a visual representation really helps for this step, especially as we get into different cases. Okay, some of you, as we practice, you might just be able to use just some of your rational thinking skills, and you'll be able to figure that out, and that's fine. Okay, but in step 3, what we have to do is we have to write a solution. Okay, the solution has to be both greater than 8 and greater than equal to 10. The solution has to be both greater than 8 and greater than or equal to 10. And we're going to write that as an inequality. Okay, now I think you guys could tell me what are numbers that are both greater than or equal to 10 and greater than 8? 10. What else? 10, 12, 13, 14, 15, 16, right? Okay, the visual representation is on a number line. So you can graph both of these. So x is greater than 8 and x is greater than or equal to 10. And you can see where they overlap each other. So do you guys remember how to graph on a number line? You have a closed circle for equal to. So if it's greater than 10, it's going to the right side. If it's greater than 8, it's an open circle, still going to the right side. So the place where they overlap is at 10 and above. So for case 1, the solution would be x is greater than or equal to 10. This is your case 1 solution. If the LCD is positive, x has to be greater than or equal to 10. Okay, but now we have to consider the negative case. The negative case, once you've done case 1, goes a lot quicker because you've already done the solving. Okay? And you don't have to write the step 1 out again, like where you're solving it, because we're just going to take a shortcut. Remember, we said if we multiply by a negative, what happens to the sign? What happens to the sign if you multiply by a negative? Yeah, it flips. So all of your work would be the same. The only difference is at the end of it, the sign would be going a different direction. Okay? So instead of x being greater than or equal to 10, if the LCD is negative, x would be less than or equal to 10. Okay? And that's because the sign flips when you multiply by a negative, which is what we would have done. So we're saying that the LCD is negative. LCD is x minus 8. You multiply by x minus 8 and it's negative, that sign flips. Okay, so for step 1, you can just do that. You've already solved it once, you don't have to solve it again. For step 2, we're going to do the LCD. Now if it's negative, okay, it has to be less than 0. Your LCD stays the same, it's still x minus 8, and then you would add it to both sides. And then your step 3 is to find where both of these happen at the same time. So where is x less than or equal to 10 and less than 8? Okay, so if you're a visual person, this will definitely help you. If you're somebody that can do that part in your head, you will just, your step 3 is going to be the case 1 solution, okay? So x is less than 8. X is less than or equal to 10. Sorry, I should have colored them this. Okay, and then we're just going to find where they overlap each other. So the solution for case 2, do you guys think you could write that out based on our number line? So it's where they overlap. So it's going to be x is less than 8. Okay, now once you've done those two cases, okay, once you've done those two cases, you have to put them together. That's your final solution. All right, so for the final solution, you ask yourself, can x be greater than or equal to 10 and less than 8 at the same time? If the answer is yes, you can tell me a number. So can x be greater than or equal to 10 and less than 8 at the same time? Are there any numbers that are bigger or equal to 10 but are less than 8? No. Okay, so if the answer is no, you connect both solutions with an or. So your final solution for this would be x is less than 8 or x is greater than or equal to 10. And then to check this, you could plug in some values, right? If x was less than 8, it could be 9, right? So if you plugged in 9, 9 minus 8 is what? Oh, I said 9. Is 9 less than 8? No, okay, so if you plugged in 9, right, which is in between these two, you'd have 6 over 1. Is 6 less than or equal to 3? No, so that's not in our solution. But let's actually try a number that is less than 8, like 7. If you plugged in 7, this would be 6 divided by negative 1, which is negative 6. Is that less than or equal to 3? Yeah. What would be a good one to try to check this interval? Okay, yeah, we can try 11. So 6 over 11 minus 8 is 3. And then 6 divided by 3 is going to be 2. So would that one work? Yep, 2 is less than or equal to 3. Great. All right, now that we've done that once, okay, I'm going to help you through the next step because I know there's a few different cases there. And then the process will go a little bit quicker this time. So you have 6 over x minus 2 is greater than or equal to negative 4. And you can just start right away with your positive case. Okay, so when you're doing this on your homework, I do want you to say what your cases are. You can say case 1, or you can say the positive case with case 1. Just make sure you say which one's positive, which one's negative. And your first step is always going to be to solve this. And when you say this is positive, that means you're multiplying both sides by a positive here. So I'm going to multiply both sides by what? Yep. So those will cancel. Okay, and then go ahead and solve that. And then remember your one rule, okay? So with inequalities, and then when you are solving this, you do have to be careful of your splitting. Okay, so the minus 8 on both sides, negative 2. Now, look, what are you doing in this step? Yeah, so when you divide by a negative, you got to remember to do what? Yeah, so this guy flips. You got to flip it there. And then negative 2 over negative 4 is? Yes. Okay, so then your solution is x is greater than or equal to 1/2. Okay, so you divided by a negative here. Divide by a negative, so that's why you have to flip the sign. Okay, and then for step 2, this is where you take the LCD. So what is your LCD here? It's just the denominator. What's the denominator? Okay, so we're going to set that. We're doing the positive case, right? So greater than 0. So x is greater than 2. And then step 3 is just finding that overlap, okay? So to simplify those two equations, so it has to satisfy those two conditions. So what we're doing in step 3 is we're simplifying these two inequalities. X has to be greater than 2 and greater than or equal to 1/2. And if you can find where the overlap is, then you know what the simplest equation is. So if x is greater than or equal to 1/2, you have a closed circle, goes to the right. If x is greater than 2, you have an open circle, goes to the right. And then you can look and see where your overlap is. And once you see it's lined up with the 2, you know that your solution for case 1 is x is greater than 2. Okay, so that's your case 1 solution. Now we're ready for case 2. Okay, so for case 2, this is going to be where the LCD is negative. Okay, now we know when we multiply by a negative, what happens is the sign switches. So for step 1, x is less than or equal to 1/2. So it's the same as your step 1 here, it's just the sign flips. Okay, and then for step 2, you take your LCD, x minus 2, and that has to be less than 0, so x is less than 2. And then step 3 is about finding the simplest inequality for those two. Okay, and that's going to be where they overlap on a number line. So like I said earlier, some of you are going to be able to do this without drawing your number line, and that is perfectly fine. You would put your case 3 solution there. Okay, so if you feel like you're good at doing this without it, that is perfectly fine. So x is less than 2. X is less than or equal to 1/2. And then we're finding this overlap here. So x is less than or equal to 1/2. Alright, so can these happen at the same time? Is there a number that's going to be greater than 2 but also less than or equal to 1/2? Nope. So then your final solution is going to be x is less than or equal to 1/2 or x is greater than 2. Notice you always want to put the less than 1 first. This is your final solution here. Okay? Alright, so I want you to do this one by yourself. Let's see how this goes, how we can do. I'm not walking you through it, okay? Give me 1 second. Alright, let's check in and make sure we're on the right track for case 1, okay? So, case 1 is the positive case. So when you take 9 over x plus 3 is greater than 6. When you multiply by x plus 3, you know it's a positive, so the sign won't switch. So you have 9 is less than 6x plus 18. Okay, and we know the sign won't switch because we're dealing with the positive case here. So then we're going to subtract, divide by 6. Now, you're dividing by 6 on both sides, which means, are you dividing by a negative here? No, because you're dividing by positive 6. So the sign stays the same. It's okay that it's a negative on top. I know that can be confusing sometimes. It's always what you're dividing by. So if that bottom number is positive, you are good. This is x is greater than negative 3 over 2. Okay, so it's only if what you're dividing by is a negative. Okay? Alright, and then so that's step 1. Step 2 is going to be setting the LCD x plus 3, and it's positive, so it's greater than 0, so x would be greater than negative 3. Now, negative 3 over 2, what's another way I could say that? Yes, so negative 1.5. So on your number line, -3 comes first, -3/2 comes second, right? Because on a number line, the lowest number goes first. Okay, so then x is greater than -3/2, and x is greater than -3, so this is where they overlap. So case 1 solution is x is greater than -3/2. So this is your solution for case 1. Okay, thumbs up if we got that correct though. No, you could write it as a decimal. Yes, if you wrote x is greater than -1.5, that is perfectly fine. All right, now let's talk about the negative case. So for step 1, all you have to do is flip that sign. Really, have you guys started to notice for step 2 it's the same thing? It has to be less than 0, so x is less than -3. Okay, so now we just got to find that overlap. So -3, -3/2. Okay, so x is less than -3/2, x is less than -3. Find your overlap. So then your case 2 solution is going to be x is less than -3. Your final solution is combining those two together. Okay, so the final solution is going to be x is less than -3 or x is greater than -3/2. Now some of you are probably thinking, okay, well, these two have never happened at the same time yet, right? We've always connected them with an or. There is another type, okay, and starts off very innocently, looks the same as the other ones. So you have 8/x plus 6, okay, is greater than or equal to 2. Okay, so I want you to do case 1.